Okay, so here's my unit circle. Okay, so we're going to continue from yesterday. I'm going to give you some definitions of some measures inside this circle. Okay, so again, this is 0.10, 0, 1, -1, 0, 0, -1, and every angle open with relative to the positive side of the x-axis, there is a corresponding point on the circle. Okay, it's called the trigonometric point, and we're interested in these coordinates as a function of the angle. Okay, so we said if the angle is 0, the coordinates is 1, 0. If the angle is pi over 2, right, pi over 2, 90 degrees, the point will be 0, 1, and so on. So let me give you some definitions here. Okay, so I'm going to open a certain angle, okay, a radius at a certain angle, theta. Okay, so this angle here is theta. Okay, just like we did yesterday. Okay, so obviously this measure from here to here is, of course, 1. This we know because it's a radius. Okay, and the y component of this point, okay, has a name. You know what that name is? How do you call this y component? Anybody know? Okay, well, this component here is called the sine of theta. Okay, so this height here is called the sine. Okay, then the x component of the point, which is this length here. Okay, this is called the cosine. Okay, so I'm just giving you some definitions. Okay, so that you know exactly where the sine and the cosine come from. Okay, then I'm going to draw a tangent at 0.10, so a tangent line right here. Okay, and I'm going to extend the radius until it crosses the tangent. So I'm extending this, the radius you're extending until it crosses the tangent, so right here. Okay, and this measure here how do we call this?
Done.
This is called the tangent of theta. Very good. Center this. So this is called the tangent of theta. Okay, good. And this length, okay, so from the origin until, so the extended the radius until it crosses the tangent, this also has a name. Does anybody know this one? From here to here.
Cotangent?
Nope.
Secant?
Yeah. Okay, so this is called the secant of theta. Okay, so secant means crossing. Okay, so two lines are either parallel, okay, or they're secant. Okay, secant means they cross each other. Okay, so obviously the radius crosses the tangent. That's why it's called the secant. Okay, any questions? So far so good. So just definitions. Okay, so very important to note that this is 90 degrees and this is 90 degrees. Okay, let me draw now a tangent, but on top here. So tangent at point 0,1. So from point 0,1, I touch a tangent, which is a line that just touches the circle at 1 point. Okay, and then I'm going to extend the radius again, okay, until it crosses the top tangent. Okay, so it crosses here now. Okay, so this length up there, what's it called?
Cotangent.
Yeah, this is called the cotangent. Okay, so this is called the cotangent of theta. Okay, so again, this is 90 degrees. Okay, and one last measure that I need is this measure from the origin until that point here, which means where the radius, the extended radius crosses the cotangent. So this length here. What's it called?
Cosecant.
Very good. Okay, so this is called the cosecant of the line. Here we go. Okay, so this little diagram you have to know by heart. Okay, because you're going to see that we're going to extract a lot of information from this little picture that I showed you here. Okay, so clear? Again, 1 the radius, the y component, the x component, sine, cosine, tangent here, cotangent on top, and cosecant and secant, which are the extended radius. Okay. Okay, so everything that is vertical doesn't have a co. Everything that's horizontal has a co. So cosine, cotangent, it's horizontal, and cosecant, which corresponds to the horizontal. If you want to remember this way, okay, but just for you to know. Another information that we could conclude from here or deduct is that this angle is what? What's this angle?
Theta.
What is it?
It's the angle that it's theta.
It's theta. Okay, so this is theta. Why is that? Why is this theta?
Because they're alternate. I don't know how to say it in English.
Okay, very good. They're alternate interior. Okay, so you have two parallels cut by a secant. Okay, secant. Two parallels cut by a secant. These angles are alternate interior. Okay, or alternate if you studied in French. And so they're congruent if these two lines are parallel, which is the case here. Okay, good. Questions? All right, let's go. So let's see what information we could extract from here. Okay, so I'm going to write here below. Let me try something here. Separate this, and I'm going to work under here. Okay, so I see here, I see 3 triangles. Okay, I don't know if you see them, but I see 3 triangles. There's the small one here. Okay, there's a bigger one here. And then there's a big one upside down here. Okay, you see it? Okay, 3 triangles. I'm going to draw them separately. Okay, under here. Okay, and we're going to work on them. So let me just redraw them. Okay, more or less. Okay, I'm just gonna go up a bit. So you see what I'm doing? Okay, so I'm just drawing these the triangles from above. Okay, and then the top one. Okay, so more or less, okay, I have my three triangles. Okay, so let me just use the same colors as above so that we really recognize them. So this was blue, this was red. Okay, and this just regular. This was my small one, then my bigger one. This. And the last one here. Okay, so these are my three triangles that I have above. And I need you guys to tell me the measures of each one, okay? Of each of the sides and each of the angles. So they're all 90 degrees here, that's easy. I'm gonna put already this, 90 degrees, that's fine. Also, I know that here this is theta, and this is theta. So I'm gonna write this down. All the information I have, I'm gonna write. Okay. Okay, so let's go on. What is this measure? Okay, so I'm gonna try to have everything in front if possible. Oh, there we go, we could have everything, could see everything. Okay, help me out. So what does this measure here? What's this?
Cosine.
Right, cosine. Good. What is this one here?
Sine of theta.
So sine theta. Okay, and what is this one here? How much is this one?
Secant.
Sorry?
1.
1.
Okay, so this is 1. Perfect. Okay, let's look at the second triangle here. Okay, so obviously this is tangent. Okay. How much is this one?
Secant.
Very good. Secant theta. Okay, and how much is this one on the bottom?
Cosine. 1.
1.
1. Perfect. Yeah, so it's 1. Okay, so it's from the origin until the edge of the circle, which is a radius, which is 1. Okay, let's go. Last triangle. So the top here is obviously cotangent theta. I see it. Okay, This one here is what? How much? How much is this one? Cosecant theta, you agree?
Yes.
Okay. And this one here is how much?
1.
1 also. Okay, it's 1 because it's this measure, again, from the origin until, okay, it's a radius. That's 1. Okay.
Sorry,
Yes?
why is it cosecant theta and not secant theta?
Why is it this one here?
Yeah.
Because it's, if you look at the triangle, it's from here until here, right? We're talking about this big triangle. You see it?
Yeah, but the cosecant
Yeah,
line.
the cosecant goes from the origin until here. The secant stops at here. And 1 stops here. So I have 1 secant, cosecant.
Okay, thank you.
Okay. Okay, any questions before I continue? Okay, good. So let me now work. I'm going to try to fit everything in here. Okay, so the first thing is that they're all right triangles. So since they're all right triangles, then I could use Pythagoras theorem, okay? Because they're right triangles. So this squared plus this squared equals this squared, okay? So right away, so using, I'm gonna write a bit smaller because I have to fit everything here. Theorem, okay? So we have sine squared plus cos squared equals 1 squared. So sine squared theta plus cos squared theta equals 1 squared, which is what? Okay, so when we write sine squared theta means sine theta, all of that squared. Okay, it's just a way to write it. We don't want to write brackets. It's too annoying to write every time brackets. And we don't want to put just the power 2 there because you're going to think that the power 2 is just on the theta. Okay, so this means sine theta, all of that squared. Okay, questions? Okay, so let's do the same thing for this triangle. So 1 squared plus tangent squared equals secant squared. So 1 plus tangent squared theta is equal to secant squared theta. Okay, and the last one is this one here. So 1 plus cotangent squared theta equals 2 cosecant squared theta. So these are 3 identities. I'm sure you learned them in high school. Okay, and if they showed you where it's from, good. If not, here, you could just, once you know your circle, where everything is in your circle, is just noticing Pythagoras theorem. That's all. Are there any questions? Okay. Let's go. Now, these 3 triangles are all, they all have angle, angle, right? Angle, angle. So all angles, all corresponding angles are the same, okay? So how do you call such triangles where you have angle, angle? Remember this? No? Okay, 2 angles the same, theta, theta, 90 degrees, 90 degrees. Obviously, the other angle is the same also because they add up to 180. So these triangles are called similar. They're similar triangles, right? Okay, or semblable if you learn in French. Okay, so all 3 triangles are similar. Okay, so since they're similar, the corresponding sides are proportional. Okay, it means that if I do this over this, this over this, this over this, is the same ratio. Okay, so let's do, for example, tangent divided by sine has to be the same thing as 1 divided by cos. Okay, so let me write this down. Tangent theta corresponds to the sine, so divided by sine theta is equal to 1 divided by cos. It's 1 over cos theta. And if I isolate tangent, it's going to be sine theta over cos theta. Okay, so I'm sure you knew this, that the tangent is sine over cos. Okay, well, that's what it's from. Questions? Okay, let's do the same thing now with secant. So secant over 1. So secant theta over 1 is equal to 1 over cos, which means that secant of theta is 1 over cos theta. Okay, same thing with, let's compare now the last triangle with the first one. So cotangent over cosine, right? Cotangent over cosine is like 1 over sine. So try to fit this again, it's really tight. So cotangent theta over cos theta is the same thing as 1 over sine theta, which means that the cotangent of theta is cos theta over sine theta. Okay, and the last one is cosecant theta over 1 is equal to 1 over sine, which means that the cosecant of theta is 1 over sine theta. Here are your basic identities. Okay, 1, 2, 3, 4, 5, 6, 7 identities. Okay, but I am sure if you've done trig before, you for sure have seen them. Okay, any questions? Okay, so there's more to say. There's a few more identities. Okay, should I? Yeah, I'm here. I'm gonna write them for you. Okay. So could I take this out? This paper out? Yeah, anyways, I want to post the sheets, the notes. So let me show you a few more identities, maybe 2 more or 3 more. Okay, and then we're ready to go back to calculus. Okay, so some important identities. Okay, so the first one is that if you have the sine of A plus B, okay, well, this is equal to sine A times cos B plus sine B times cos A. Okay, it's important. Okay, we're going to use this. Okay, another one is if you have the cos of A plus B, this is equal to the cos of A times the cos of B minus sine of A sine of B. Okay, so you have to know these ones. Okay, I used to forget them always, but with time it stays. But they're hard to remember. Okay, but you're going to see after count 2, you'll never forget this. Okay, so just one consequence of this. If I do sine of 2x, what's it going to be? Okay, so sine of 2x is like sine of x plus x. So it will be sine x cos x plus sine x cos x. So it will be 2 times sine x cos x. Okay, that's a consequence of this. And same here. Cos of 2x will be what? Cos x minus sine x. Okay, so imagine A is x and B is x. So just replace A and B by x. Okay, so it's going to be cos squared x minus sine squared x. Okay, there's many more, but that's all we need for now. Any questions? Okay, so for the exercises, I'm gonna let you, if you want to do them, you don't have to, because this is not in this course, but you have the pre-calculus worksheets, trigonometry part 1 and trigonometry part 2. It's all there. Okay, you have questions and the answers. Okay, let's go. So last part of limits. Let's go back to limits now. The last little part before we go to continuity. Okay, so limits involving trigonometric functions. Okay, so this is important. What I'm going to do now, it's going to get a bit tricky. Okay, so if it's not clear, you stop me. So there's 2 things you need to know. One is that the limit as x approaches 0 of sine of x divided by x equals something. And the second thing you need to know is that the limit as x approaches 0 of 1 minus the cosine of x over x is equal to something. Okay, so if you plug in 0 here, you get sine of 0 is 0 over 0. So 0 over 0. On this limit, you have to know that it's going to give you 1. Okay, we're going to prove it in 2 minutes. And this one here, if you plug in 0, so cos of 0 is 1. 1 minus 1 is 0 and over 0. So you have 0 over 0. And this limit, it gives you 0. Okay. So let's start by proving this. Okay, so we're going to prove this one. This one's harder to prove. Okay. And once this is proven, this is going to be easy. Okay, but we have to prove this one first. And this requires some, a bit of thinking. Let's go proof. Okay, so we're dealing with trigonometry. So let me draw the circle again. I want to draw my unit circle because everything's happening there. Okay, so I will go, let's say here, let's draw. Okay, so again, the unit circle. Okay, so X, Y. So this is what I'm going to do. I'm going to draw a triangle. Okay, so I'm going to draw first. I open an angle here. Okay, just as usual, like we did it before. At an angle here, let's call the angle, say X. Okay, and I'm going to draw a triangle like this. Okay, so here's my triangle, you see it. And I'm going to draw another triangle, which is, I'm going to draw a tangent here. And extend the radius until it reaches the tangent. So I'm drawing the secant now. Okay. And so now I see three regions. So let me draw the three regions. The first one will be this little triangle here, which I'm going to draw in blue. Okay. Then I'm going to draw the big triangle, which I'm going to draw, let's say, in green. Oh, gosh. Okay. And the last thing I want to draw is another region here, which is the sector here, sort of the slice of pizza. I don't know if you see it, it's right here. This, and it goes here. Okay, so I'm putting it in red. Can you see three regions? Okay, I'm going to separate them here. Okay, I'm going to redraw them. This is getting kind of messy here. Okay, so let's do it like this. So the first one is the blue. Then there is the red. And then there's the green. Okay, so okay. And the small one here. Okay, and the last one, which is something like this. The green does that. Okay, so I have my three regions. Okay, so this one is definitely, this area is definitely smaller than this one, which is definitely smaller than this one. Do you agree with this? Okay, the blue, as you see, the blue is inside the red and the red is inside the green. So this area, this is the order. Any questions before I continue?
Why smaller or equal?
Well, if they're smaller, then they're definitely smaller or equal. Okay, 5 is smaller or equal than 10, for sure. Okay, so I'm being safer, but you're right, it's smaller. You're right. Okay, but nobody stops me from writing smaller or equal. You'll see why at the end. Okay, any questions so far? Okay, so this region is smaller than this region, which is smaller than this region. So let's find the measures of each of these regions. Okay, so the area, of course, the area of a triangle is base times height divided by 2. So I need to find the base and the height of each of these triangles and an area, a way to find the area of this sector. Okay, so let's start with this measure here. Okay, so what is how much is the base?
1.
1, right? We're in the unit circle, right? So this is 1, 1, minus 1, minus 1. So this is definitely 1. How much is this? How much is this height?
10x.
Very good, 10x. You guys with me? Yeah, any questions? Okay, so this is 1, this is 10x. Here, how much is the base?
1.
1, good. And now the height, I didn't draw the height, but let's draw it now. Degrees. How much is this?
Sin,
How much?
sin x.
Very good. Sine x. Do you understand why it's sine x? Because the height here, if I go back to my circle, this height is the sine of x. Okay, so this here is sine x. Okay, let me write down the area here. So the area is 1 times sine x over 2, right? Base times height over 2. Smaller than or equal to, smaller than or equal to, and this would be 1 times 10x over 2. Questions? Okay, no questions. That's good news. This angle x, this is angle x, this is angle x. How am I going to find the area of this sector now? Can you tell me? Okay, so don't forget, this radius is, this is 1 and this is 1. How do I find the area of this sector? Do you remember how to do this?
You do the big triangle minus the small triangle.
Sorry?
The big triangle minus the small one.
The big triangle minus the small triangle? Who said that? I can't. Okay, it's fine. I just can't see who's talking, but if you do big triangle minus small triangle, you're going to get this region here. Right? right? The big triangle minus the small triangle, you're going to get this little triangle here, which is not what I'm looking for. So that's not good. Okay, how are we going to find the area of this sector? So I'm going to take a little section here and show you how to do this. Unless somebody wants to try, that would be even better. I'll try to fit it here. So area of a sector. So this is, you probably did this in secondary too. So you probably forgot this. Okay, so you do central angle over 2 pi, which is 360, okay, equals to the area of sector divided by the area of the whole circle, okay, which is pi times radius squared. Okay, so applying what we know from this, okay, so what do I have? So the central angle is x over 2 pi is equal to the area of the sector, which is what I'm looking for, A, area, over pi r squared, but pi, but r is 1, so this is just pi, because the radius is 1. Okay, so this is, if you want, 1 squared. And if I isolate A, which is what I'm looking for, the area here, it's going to be, so you cross out the pi's, so it's just x over 2. So this here, this area will be x over 2. You understand what I just did?
Sorry, can you read the formula, please? It's not clear.
Oh, sorry, which one? On top here?
Yeah, I can't read it.
Okay, yeah, sorry, because I lost space. So this is called, this is the central angle divided by 2 pi is equal to the area of the sector divided by pi r squared. And if I lift it a bit, maybe you could see better. Can you see better?
Yeah, thank you. It's all right. Thanks.
Okay. Okay, we're almost done. That was the hard part, was finding this guy. Okay. So at this point, we're almost done. So let's go. I'm going to get rid of the 2's right away. So I will multiply everything here, all sides. I will multiply by 2. Okay, and so I have here that the sine of x is less than or equal to x, which is less than or equal to tangent. But tangent is what? What's tangent? We showed it a few minutes ago. Tangent is sine x over cos x, right? Sine x over cos x. Because this is equal to tangent. Any questions? Okay, so what I'm going to do now, I see that I have a sine here, I have a sine here. I will divide everything by sine. Divided by sine x. Okay. So on the left, I have 1. In the middle, I have x over sine x. And in the right, I have 1 over cos x. Are there any questions until now? Okay, so again, I found 3 regions. I noticed that this one is included in this one, which is included in this one. So the area of this is smaller than the area of this, smaller than the area of this, which leads me to this inequality. Okay. So area smaller than this area, smaller than this area. And then I just did some algebra, first of all, getting rid of the 2's. They're out. That's what I'm left. And then I'm going to get rid of the signs, which, by the way, is very useful because I recognize now x over sine x, which is, I wanted to prove sine x over x. So it's starting to look what I'm looking for, what I'm looking for.
Sir,
Yep.
I don't understand what you did in this second part. Did you multiply by minus sin x?
Oh, here, I divided by sine x. Oh, you can't see it, is it too small?
Ah, you divided. Okay, thank you.
Yeah, so I'm going to write bigger, sorry.
It's okay.
This you can see well? So what I'm going to do now is I'm going to flip everything, okay? So if I flip this, I flip this, I flip this, I will get 1. Here I will get sine x over x, and here I will get cos x over 1. Okay, except that I have to change the signs because I flipped everything. Okay, so I just showed that sine x over x is always included between 1 and cos x. I just showed this. Okay, so if it's always included, you have a question? Okay, so if it's always included between these 2 values, so even if x is very small, it's still included there. So I could take the limit of each side. So limit as x approaches 0 of 1 is still bigger or equal than the limit as x approaches 0 of this, which is still bigger than limit x approaches 0 of that. Okay. Limit as x approaches 0 of 1, well, this is 1. Limit as x approaches 0 of cos x is cos of 0, which is 1. So I just showed that the limit is between 1 and 1, so it has to be 1. There's no choice. Do you understand? And that's my proof. Therefore, limit as x approaches 0 of sine x over x is equal to 1. That's it. Okay, that's the proof. And this is called, this process here of squeezing it by limit between 2 numbers that are the same. This is called the squeeze, it's called the squeeze theorem. Okay, we're going to do a few examples using the squeeze theorem soon. But for now, what I want you to know is that the limit as x approaches 0 of sine x over x is 1.
Sir, can you lower the page a little bit, please?
You mean you want to see the top or the bottom? Like this?
A little more, please.
Or you can't
Yes.
see the bottom?
Thank you.
Yeah, we can't see the bottom.
That's weird. I could see the mine. Okay. So let me just move a bit. Is okay?
Yeah, thank you.
Sir, can you explain that again?
Which one?
The last part, where like the
Sorry,
yeah, all that.
from here?
Yeah.
Okay, so do you understand that this is good? Do you understand this part here before?
Yeah.
Okay, so this is okay. Here, what I did, first thing I did is I flipped everything. So 1 over 1, I flipped. X over sine x changed to sine x over x. And 1 over cos changed to cos. Good?
Yeah.
Okay, when I do this, I have to be careful and change the signs. Okay, because if 1/2 is bigger than 1/4, if you flip it, you get 4 is bigger than 2. Okay, you have to flip the sign as well. Okay, if you flip it. So that's the first thing I did. So 1 is greater or equal than sine x over x, which is greater or equal than cos x. Then I said, 1 second, this is always true for all x. So even if x is very, very small, it's still gonna hold. Okay, so if x is very close to 0, it's still between, this limit will still be between limit x approaches 0 of 1 and limit x approaches 0 of cos x. Okay, so this is still squeezed between these two values. But as x approaches 0, this is getting close to 1, this is getting close to 1. So the closer I am to 0, the closer this value is to 1. I'm squeezing it, narrowing down to 1. That's what it is. Is this clear?
Yeah, thank you.
Okay. All right, let's do some exercises to apply this. Okay. You okay? Can I change page?
I have a question.
Yeah.
Why is the cos x equal to 1?
Excuse me?
Why is that like cos of x equal to like times equal 1?
Why is this one? Because x is approaching 0. So if you do the cosine of 0, right, the cosine of 0 is 1.
Okay, thank you.
Okay. Okay, let's go. Let's do some examples. So we're gonna do a few. And now you should be able to do every exercise in the limits worksheet, okay? Even if you see sine and cosine, you should be able to do it. So here are a few examples. I'm gonna write bigger, okay, because it seems that there's an issue. So evaluate the following limits. So first, let's start with an easy one. So limit as x approaches 0 of sine 2x over 3x. Okay, so let me do the first one. So it's equal to limit x approaches 0 sine 2x over, so 3x, so this is a number, and so the number you can always pull it out of the limit. Okay, so this I could pull out 1/3. Okay, so the limit is very, very friendly. Okay, you could put it wherever you want the limit. Okay, I could do the limit up here, the limit down here. I could put it the limit every time, every place there's an x, I could put a limit there. Okay, it's just chances are you're going to end up with a undetermined form. Okay, so if you plug in 0 here and 0 here, you get 0 over 0, so it's useless. So but anything that doesn't have an x, you could pull out of the limits. Okay, so I have sine 2x over x. That's not good because I want either sine x over x, that I know it's 1, we just showed, or sine 2x over 2x, that would be good as well. So I need a 2 here. If there was a 2 here, this would have been 1. Okay, so what do I do? Well, I'm just going to put the 2, and I'm going to multiply by 2. Okay, and that way, this is 1, because it's sine of 0 over 0, right? Sine of 0, sine of something over something, and these things go to 0, and they're the exact same thing. Okay, And now I could pull out the 2 outside. So 2/3 times limit as x approaches 0 of sine 2x over 2x. And now this I know that it's 1. And so my answer is 2/3. Is it okay?
So for
Yes,
each problem, you basically like put in what you want just to make it 1.
Excuse me? What do you say?
For problems like this, you basically put in numbers what you want just to make it equal to 1,
Yeah,
right?
exactly, exactly. So I want to recognize sine A over A, sine W over W. Whatever that is here has to be here, and make sure that they both go to 0, and you're good. Okay?
Sir, I didn't understand the part where you took out the 2. Could you explain it again, please?
When I did what?
When you took out the 2?
So from here to here?
Yes, please.
Well, this 2 does not depend on x, so I could just pull it out. That's all I did. I factor it outside the limit. You could do that. That's it. Does that answer your question or no?
Yes.
Okay. Okay, let's do a few more. We need quite a few more, okay? Because you're going to see some of them get more complicated. So try one now. I'll give you the same level of difficulty. So limit x approaches 0. Let's say sine 5x over 6x.
We just say it's 5/6.
Excuse me?
We just say it's 5/6.
Can we just say that?
Could we say it's 5/6 the limit? Because
Why? Lazy, you don't want to write? You don't want to write what I wrote here?
well, if it's gonna come out to the same logic, we might as well just make it general, no?
Not yet.
It's different for every
You're
exercise.
too early in your calculus career to start skipping steps.
All right.
Take your time, do it well, or else you're gonna have trouble. Okay?
Okay.
The answer is gonna be 5 or 6. It's the exact same thing as this, but I could twist it just a little bit, and you'll see it's not gonna work. Okay? So you have to go slow.
Okay.
Okay? So go ahead, do it. You all got it right? Yeah, it's easy. Okay, let's go for something a little more complicated. Okay, what should I do now?
multiplied by 1/3.
And then what?
Do we multiply by 1/3?
I don't know. What's going to happen? Are you the one who I don't know who spoke before, but you're the one who said 5 over 6 here?
Yeah,
Okay. So why don't you do here 3 over 7?
not sure.
Exactly. Okay. So that's why go step by step. Okay. So any suggestions? There's a square here. So the square is bothering me, right? So I'm going to go like this. So sine squared of 3x is the same thing as sine 3x, all of that squared, right? Divided by x squared. So that's I just rewrote it so that you could see it clearly. I put the power 2 here. Equals 1 over 7, limit x approaches 0, and then I could put everything to the power of 2. So sine x over x, all of this power 2. Get with me? And okay, I'm gonna write here because I want to finish in this paper. So equals, so 1 over 7. And I told you the limit, you could put it everywhere you want. So I'm going to put it inside the square. So I'm going to go like this. Limit x approaches 0, sine 3x over x, all this to the power of 2. Are we good? So this I know how to do, right? I'm going to multiply by 3 here and by 3 here. Okay, and then I want to extract the 3 outside the limit and then outside the power. So it'll come outside as a 9. Okay, so I will have 9 over 7 times limit x approaches 0 of sine 3x over 3x squared, which this I know it's 1 squared, so the answer is 9 over 7.
How would it be 9 over 7 when you take out the 3?
How would it be 9, you mean?
Yeah.
Because, okay, the 3 is here, so it's power 2. So the 3 becomes power 2, and the limit becomes power 2. Everything becomes power 2. So the 3 power 2 becomes 9.
Okay, and you don't have to put the limit inside the brackets if you don't want to, right? Like, what does that do?
Oh, you leave it like this, you mean?
Yeah.
Because this, I don't know. I don't know what that is. This is already a big algebraic expression. This, I didn't teach you this. I taught you just sine x over x. So I need to recognize limit sine x over x, limit sine 3x over 3x. This I know it's 1. If I pull it outside and everything's power 2, I don't know anymore. It is 1 in this case, but you couldn't assume that. Understand? I really need to have this form, limit sine x over x. I need to have this. That's what I know is 1. That's what I showed. I didn't show anything else. Does this answer you?
Yeah. Thank
Okay,
you.
we'll do another one anyways. Okay, we'll do another one now. Yeah, the same type as this. Okay, let's go. So that was number 3, I guess, or number 4. Limit as x approaches 0 of sine cubed of 4x over 2x cubed. Okay, go for it. Same process. Sorry, I'm moving the camera. Anybody got this right?
Why didn't we just do times 2?
Excuse me?
Why didn't we do times 2 on top and on the bottom? And then we take out the 2 from the top, and then we're gonna have sine 4x on 4x.
I don't understand. Which two are you talking about? I don't understand. I pulled out a half here. Okay, then what?
No, but the 2 at the bottom, we could just do times 2 to have 4x cubed. And
Okay.
we're gonna have 2 sine cubed for 4x. And then we take out the 2 on top, and then we're gonna have 2 sine cubed x4 on 4x cubed.
Okay, and then what?
And then we
And then what?
and then we take out the 2 from the numerator, and then we do 2 cubed.
No, this is wrong. Okay, let me just write it on another piece of paper, what you're telling me to do, and I'm going to show you why it's wrong. Okay, are you done writing this?
Yes.
I'm going to put it back in a minute. Okay, I'm just going to see, I'm going to go through your logic. So you're telling me limit x approaches 0, sine cubed 4x over 2x cubed. So you're telling me, if I understand, so I will multiply by 2 top and bottom. So it's 2 times limit x approaches 0, sine cubed 4x over 4x cubed. What you're saying?
Yes.
And then what?
And then we put everything in parentheses, and then cube.
Okay. Everything cubed, like this, so like this. So sine 4x over 4x like this cubed.
Or just the fraction, not the limit. It's not gonna
Okay,
change.
like this.
Yeah.
Is that true? Is this equal to this? So you're telling me that this is equal?
Oh, never mind.
Right, that's what you said, right? That's a mistake?
Now I see it.
Okay, good. See, it's good. That's what I know that was the mistake you were doing, but I wanted you to see it. I want the class to see it also, because this is a mistake I see often. Okay, so you're not the only one making this mistake.
Why is it a mistake? I don't understand.
Why is it what?
Why is it a mistake?
Because if I want to go from here back to here, right? So I will put to the power of 3, so I will get sine cubed of 4x, and on the bottom, if I put power 3, I'm going to get 4 power of 3, which is 64x3. Do you understand that it's not the same thing?
Yes.
Okay, so that's the mistake. The 3 is on the x, it's not on the 4. Okay. Any questions?